Good afternoon, everyone. I'm Alper Ilkbahar from Intel Corporation. Welcome to my talk titled Breakthrough Data-Centric Computing with a New Memory Tier. First and foremost, I hope you, your families, and team members are all doing well and staying safe. This is a first for me. This is the first time I'm giving a keynote speech from my home, and it has been a pretty amazing 2 months. And actually, I'm really proud to be part of this community of technologists whose work makes it possible to continue our lives and work despite all the challenges. I'm also really proud of working for a company that has been able to contribute to the cause in a meaningful way and has made its mission to solve world's greatest challenges through technology innovation. So I know that the same mission energizes all of you as well, and that's why you're all here. So I'm really, really thrilled to be in front of you today. Today, we will cover data-centric computing. We all know and talk about data growth, how data-hungry applications such as AI, machine learning, big data analytics are changing our lives as we process, move, and store ever-increasing amounts of data. We rely on semiconductor technology innovation to scale with this growth. At the same time, we also understand that Moore's law has been slowing down. So engineers have been coming up with architectural breakthroughs to meet these challenges. CPUs are using package level integration with chiplets. NAND flash pushed their scaling in the vertical dimension with 3D NAND. And networking engineers are now pushing the bandwidth limits with silicon photonics. So all wonderful innovation, all made it possible to continue the scaling over the years. But the only critical technology that has not delivered such a breakthrough actually is the DRAM. And that's what I'm going to talk to you about on this slide. On the graph to the left, we are showing you how DRAM scaling went through over the past 4 decades. You can see in 3 phases how scaling went in the 90s, where it was in what we call phase 1, scaling more or less right along with the original Moore's law, about 4x in 3 years. Then in the 2000s, we entered a phase 2, and finally these days, a phase 3, where scaling is down to only 2x in about 4 years. So what I have done on the graph to the right is plotting these capacity growths of phase 1, 2, and 3 of DRAM against the data growth. The data growth is depicted in the yellow line here. As you can see, if DRAM continued on the original phase 1, the Moore's law, it would have easily handled the data growth. And even in phase 2, it would have kept up with it. But in phase 3, which is what we are experiencing today, the DRAM growth is increasingly falling behind data needs. So this exponential gap between what we need the technology to do and what we're really getting is going to drive some architectural disruption, and that's what we should be all expecting. For us at Intel, this disruption is called Optane. This is a new technology we're bringing to the market. Really excited and passionate about this so that we can re-architect the memory storage hierarchy. We don't get to do this every day. It's once in a lifetime opportunity that we are really privileged to experience here. And then with the Optane technology, what we're set out to do here is with the SSDs, the Optane SSDs, we are pushing the storage performance to the next level. And with the persistent memory, Optane persistent memory, which in itself is a category, we're pushing the memory capacity to the new limits with incredibly better economics. So our vision for the future with the persistent memory really is creating a 2-tiered memory architecture where DRAM is going to still exist, but going to be essentially a bandwidth tier, and the capacity tier is going to be implemented with the persistent memory. So the very first product in our vision for the Optane persistent memory is launched last year in April. With this product, we're bringing you big and affordable memory. it comes in capacities of 128, 256, and 512 gigabytes. In comparison, the sweet spots for DRAM, as you know, is 32 or 64 gigabytes. So we are starting already way above where DRAM can reach and go all to the capacity points that's impossible for DRAM to achieve today. Just like a DDR4 DRAM DIMM, it actually is pin compatible with your DDR4 slots, which means that you can install it into the memory slots on your second generation Xeon scalable processors. Just slide it in and it will work. And because the Optane media is inherently non-volatile, you get to implement super high performance storage at memory speeds with Optane here. The performance is unparalleled to anything that you know of. We measure latencies in nanoseconds and then not in microseconds. So you get incredible latency improvements in any storage application. We implemented in this product 2 modes of operation. The first one is called the App Direct mode. So this is for software like Aerospike that wants to take full advantage of the persistent memory capabilities, improve its performance to the absolute best levels, and also achieve persistency. However, we also thought of applications who are in the legacy domain and want to use the persistent memory without any modifications. So for those applications, we created the memory mode. And in that mode, the CPU essentially will handle transparent to the software all the memory operations, and even legacy applications can take advantage of the benefits of big and affordable memory. Also, with this product, we implemented hardware encryption for data security, and we also did strong onboard error detection and correction capabilities, as well as sparing capabilities so that you can enjoy highest enterprise level reliability. As I mentioned, we launched the product a year ago, and it's today available from all major OEMs. Now, a year into the launch of the product, based on our engagements with literally hundreds of customers, we see 3 main value pillars around Optane persistent memory. The first pillar is save more. In this pillar, our customers are typically displacing expensive DRAM with cost-effective persistent memory. And again, typically in this pillar, we're seeing workloads that require large memory footprint, such as in-memory databases. You see here examples of Redis, SAP HANA. So those kind of applications, you really don't have to do much. Just start using persistent memory without sacrificing your performance, and you get all the savings out of the persistent memory. In the second pillar, the do more pillar, our customers deploy a lot more memory than what they used to do with persistent memory now. And they use this to consolidate workloads and increase number of VMs per server. So in short, they can pack a lot more work into their existing hardware, and their investments just deliver them a lot more than what used to. And finally, in the go fast pillar, workloads experience spectacular performance improvements. And what happens here typically is workloads either solve their storage bottlenecks through persistent memory, or altogether avoid storage by putting all the data they need in the memory, which is now plentiful available. Or, as in the case of Aerospike, they implement fast restart type of capabilities that are only available with persistent memory, which was never possible before. So you put all these benefits, and you're seeing here examples of many different customers and how they achieve these benefits using persistent memory. We're really thrilled to see these kind of really meaningful improvements that you typically don't see in generation over generation type of evolutionary products. And this is only possible through a revolutionary, totally new category of product that we are thrilled to be working on. Now, just having the product out there is not good enough. In order to make the whole ecosystem work, we have been really working with a large number of partners and customers. First of all, built a really robust ISV software ecosystem around persistent memory. Here you're seeing a large number of companies who really went out, saw the value of persistent memory, and started optimizing their products around this new technology. Some of these relationships go back many, many years. Some of these partners have started adopting and optimizing their software for almost a decade around the concept, and now that it's become a reality, they're embracing it even stronger. Also in the cloud service providers, our partners, now you see the names here, are offering services, instances, and even in their moving their own workloads into Optane-based systems. And finally, our OEM and system integrated partners are offering systems and solutions around Optane. And we're really seeing and very proud of seeing this growing ecosystem. And every time I show this slide or something similar to this, I will add more names to it. And it just gives me great pleasure to see this unity around a totally new technology. Just for your reference, I also wanted to share with you one more time some of the OEM partners and their specific offerings with Optane persistent memory, so that you can refer to it. And if you want to talk to any of these partners to inquire and how you might be able to purchase Optane-based systems, please refer to this page. You'll see not only the partners' names, but also some of their servers that are supporting persistent memory here as well. Next, I like to start talking about the collaboration between Intel and Aerospike. So I've talked already about how we have been partnering with a lot of ISV partners, and Aerospike has been one such partner who has really embraced the technology, saw the value and what it could do to their offerings. And our collaboration has been really phenomenal by combining Aerospike's data platform and Intel's hardware innovation. We really are thrilled to bring great value to our customers in real-time, extreme scale applications such as digital payments, fraud detection, recommendation engines. The list goes on and on. So and I will share with you some of these results that we are really, really proud of. Now, here are some examples that are truly impressive. As I said, only possible through revolutionary technology changes. Combining Optane persistent memory on Aerospike's data platform, HPE is seeing 2,000% speed improvements in data ingestion. You don't get that in gen over gen improvements that we are used to 10, 20%. No, 2,000%. Now, similarly, Aerospike started leveraging our latest Intel Ethernet 800 offering with application device queues, or ADQ, and was able to push the transaction improvements, the transaction volumes by 75%. Again, phenomenal. And finally, again, using our Intel Optane persistent memory and the second gen Xeon scalable processor, Aerospike was able to reduce the restart times by an amazing 135x reduction. This is just a different phenomenon. This is a different paradigm we're talking about. Now, how were some of these things achieved? And I really love to talk about how Aerospike is approaching persistent memory. So first of all, incremental savings are achieved by storing indices and data on Intel Optane persistent memory, which has significantly better cost structure than DRAM. Also, with persistent memory offering higher capacity points than DRAM, as we talked about earlier, it's now possible to reduce server count and the cost. And we also touched on the incredible faster restart times, which essentially reduces your operational cost. Now, the breakthrough capacity is achieved by leveraging the capacity points of the persistent memory. We talked about that. Aerospike's first 4.5 version was storing primary indices on persistent memory. And then they went even next step further with version 4.8, and now storing both primary indices and data in persistent memory. Now, with a 2-socket system offering up to 6 terabytes of persistent memory, in a 2-socket system, 6 terabytes. This is pretty amazing. It's possible on the Aerospike platform to maintain up to 90 billion records, right? 90 billion records on a single server. Incredible. Now, the combination of the Optane and the Aerospike platform delivers DRAM-like performance, unmatched reliability, extreme scale, and low TCO. I really can't wait to see what our next innovation is going to be around in the future of this collaboration. And speaking of the future, our persistent memory journey is only in its beginnings. We are busy executing a roadmap of persistent products that is aligned to our Xeon processors. Today, we're shipping our first-gen product, codenamed Apache Pass. Our second-generation product, Barlow Pass, will be introduced along with the Cooper Lake and Ice Lake processors. And the third and fourth-gen products are also in flight. So we are pushing very hard and delivering you better and better products with every generation. If you'd like to learn more about the Optane persistent memory, understand the product better, see what kind of solutions we're offering around the product, as well as look at some of how our customers are using the product, I would like to invite you to please take a look at these resources that we're referencing on this slide. At this time, I would like to direct all participants with questions to our partner pavilion for a Q&A at Intel's virtual booth. With that, I'd like to thank you for participating and hope to see you in person in the near future. Until then, please stay safe and healthy. Thank you.